This will be an examination question for finding the equation of plane. So this is, as you know that you want to find the equation of plane, you have the formula of r dot n equals to a dot n, right? As you need to know the normal vector and the point on the plane, right? So let's look at this question. This question is actually asking you to finding the Cartesian equation of the plane, right? You have a plane, and this plane passes through a point A, 1, 2, 3. So it means that the point A is on the plane, right? So it means that I already have the information for A, which will be 1, 2, 3, right? So what I need is the normal. So normal vector will be always that tested in your exam. So where they were given you information, and the most important keyword here is the plane. Find the equation of the plane that passes through this point, and the plane also perpendicular to the line, right? Perpendicular to this line. So it means that this line is perpendicular to the plane. Means that it's orthogonal to the plane. So then this line is given as this. So I always asking students, when you see there is a Cartesian equation of the line, we always write it into a parametric form. Alright, so I need to write this into a parametric form so that I can get the direction of the line, as direction very important. Okay, then I have y over 3 equals to t, and negative z equals to t. So I have x equals to negative 1 plus 2t, as I make x become a subject, negative 1 plus 2t, and y equals to 0 plus 3t, right? Or 3t, I just write 0 here, later it will help me. So I have negative t or 0 negative t, right? It's actually negative t, right? So that I want to rewrite this in a vector form, which will give me negative 1, 0, 0. This is a point. This is not so important, but the important thing will be the vector here, the one that coefficient of t. So 2, 3, and negative 1. Why? Because this is a direction of the line, right? Means that this line is having the direction of 2, 3, negative 1, right? 2, 3, negative 1. So what is so important about the direction of the line here? So because look at the question. Find the Cartesian equation of the plane that passes through this point. This is okay, right? But you know that when you want to find the equation of the plane, you need the normal, right? So what is the normal of this plane? So I tell you that the normal of the plane is perpendicular to the plane, right? It's a normal vector. So depict the direction of the plane. So if you see that this line is perpendicular to the plane, right? So when it's perpendicular, what can you say? Then I can say that the direction of the line, the straight line, is parallel to the direction of the normal vector of the plane, right? Because why? This is a normal plane, and this line coincidentally is perpendicular to the plane, right? So I can say that the normal vector is also can take the direction vector of the plane. So this is the most important concept here, right? Which I can directly taking the direction vector of the line as the normal of this plane. Why? Because both of them are parallel. This is a normal and this is perpendicular to the plane. So I can say that the normal is the direction of the line. So with this information, I have the normal, I can finding the equation of the plane, right? Okay, so as you know that is r dot n. Your n will be 2i plus 3j negative k and equals to a dot n. A is a point on the plane, which is 1, 2, and 3. Dot with 2, 3, negative 1, right? It's a normal. I just write in column form to help me do the dot product. So 1 times 2, 2. Plus with 2 times 3, 6. 3 times negative 1, you have negative 3. So 6 plus 2, you will have 8. 8 minus 3, you're getting 5. So now you know that the vector equation of the plane will be 2i plus 3j minus k equals to 5, right? This will be the vector equation of the plane. So if you see carefully, 2, 3, negative 1 is actually the direction of the line. Why you can taking this? Why you can taking the direction of the, and you always taking the direction of line as the direction of the normal vector? No. It is only you can take the normal as the direction of the line if this is perpendicular to the line. Alright? If it's in other direction, which is not parallel to the normal vector, we cannot take it. Alright? So now, and we can convert this into a Cartesian form as the question required to find the Cartesian equation. So we just write the I to be x, 3y minus with z equals to 5. So this will be the Cartesian equation for the plane. Right? That's all for this video, and we will go for more example for equation of plane. It's exam type question, which is more complicated and more challenging. Alright? Okay, see you for the next example.